Good morning. Is everybody ready to start? I think it's 11:15. So. Glad to be here. Glad it's not snowing and ice out today like it was 2 years ago. So hopefully we can get home. Just want to introduce ourselves. This talk is going to be mostly about aerial imagery, data collection, and uses for agriculture. We typically speak about uses in commercial ag. This year is going to be a little bit different. We're going to spend a little bit more time talking about some of the projects that we've been doing in research with universities, high throughput phenotyping, and Dr. Price is going to talk about that. He has been my mentor for the last 5 years and has taught me pretty much everything I know about remote sensing. So I'll cover the pretty pictures and the introductions, and he'll talk about the data. So if you get bored with me, just wait. My name is Don Cummins, president of Air Data Solutions. We started this company about 5 years ago with one airplane. A few months later, we got a drone because that was all the rage, right? You need to have a drone if you're going to take pictures for farmers. So we kind of started backwards. I've been flying since I was a kid. Spent about 20 years managing ranches in Colorado, Texas, Louisiana. And one day I got bucked off a horse, was laying in the mud in the cold, and I looked up and saw an airplane fly over. And I said, there's got to be an easier way to make a living. So started taking pictures out of an airplane, and it grew into kind of a service industry. So it's been good. It's been exciting. And we're constantly learning every day. These events and things are probably better for us than for you. Hopefully it's the other way around. But I always learn from you guys what's useful, what do you need, what do you want, and then we try to tailor what we do to fit some of the things that you guys are trying to do. So Kevin Price is right here. He's our Chief Technologies Officer. He's always looking at researching better ways to utilize this imagery and the data for not only agriculture but also other industries as well. So who are we? Kind of talked about that. We're a Louisiana-based company. I'm in Natchitoches, which is just south of Shreveport, kind of north-central Louisiana. We have an office in Texas, as well as Colorado and Kansas and Virginia. So we kind of travel all across the country. We fly, we do work on the ground, we use drones. Pretty much any kind of digital data collection we're involved in, whether it's actually imagery or it's laser scanning, LiDAR work, underwater bathymetry, inspection services with cameras and sensors, leak detection. We chase the work wherever it is. What platforms do we use? We use drones. There's kind of three types of drones. The multi-rotors. Everybody probably has or has seen the Phantom quadcopters, the white ones. They have cameras on them. Great. We fly those every day. This is a little bit bigger version of that. It carries two cameras. They're a great platform to get a camera in the air so you can see stuff you can't see on the ground. And basically what we use our drones and our aircraft for is to put a camera in the air. It doesn't matter to us what's carrying the camera as long as it's doing it effectively and efficiently. And so we are platform agnostic. If a drone fits, great. If a balloon fits or a pigeon fits, great. We'll use whatever carries that camera in the most effective way. The second type in the top left is fixed wing. It flies like an airplane. It needs some amount of runway to take off and land, but it can fly longer and faster than a typical multi-rotor drone. So it has its place. The third is kind of a hybrid. It takes off like a helicopter. It's got rotors that lift it up straight up, and then it transitions to fly like an airplane. And so it's more efficient. It can fly longer, and it can land without a runway. So It's a pretty useful platform. This particular one is about a 12-foot wingspan. It carries 7 pounds, so it can carry a large sensor that your typical smaller multirotors can't carry. And it flies for about an hour and a half, 60 miles an hour, so it can cover a lot of ground. Manned aircraft, we operate small Cessnas. They have camera holes in the bottom of them, and we'll mount different different sensors in these aircraft, and those we can take pretty much anywhere in the country, sometimes out of the country. This is an example of one of our camera systems. It's a 4-band, which means it collects natural color imagery, which is like what you're seeing with your eyeballs. It also collects near-infrared imagery, which is a little bit beyond the red spectrum. Kevin will talk more about that. Maybe y'all know already use color infrared imagery or NDVI imagery. Is everybody familiar with that in here? Okay. So this is a medium format camera. Each image is about 100 megapixels. It's great for covering a large area or getting very high resolution images. So an example of some of the other sensors that we carry, those are the ones that were in the previous slide at the top. The second one is a hyperspectral sensor. This, instead of collecting 4 bands, it collects 120. And anybody familiar with hyperspectral? You're smiling.
A little bit.
Yeah. Okay. So you use it, or you?
No, I just know how much it costs. And
you know how
one
much
day
it
it'd be nice
costs.
to use.
Yeah. I guess they charge by the band, so they aren't cheap. They're a scanner, so they don't really take a picture. They scan line by line. So as you fly along, it kind of builds line after line. And they're predominantly used for research purposes. We're using some to detect hydrocarbons for detecting oil, but they're mostly used for research because of the cost and the excessive amount of data that they produce. And don't get Kevin started on that, because he's used them a lot and he knows their place, but he also doesn't want to fool with all the extra data if you don't have to. Our operator network, these are, the yellow circles are where we operate out of, our owned assets. The blue circles are people who we work closely with. We train, we equip, we consult with, and they fly for us, so they collect imagery for us. So we have a network around the country, so if you got land somewhere and it's not cost effective for us to get to, we can call on somebody else who can do the same job that we do, and they can get over your site a lot more efficiently. Places we've worked, 2019, this is just kind of a summary map, California to Florida. We'll go pretty much anywhere. We did some work in Central America last year, and are working on some projects in the Caribbean. Would love to be there this time of year, so we give special discounts for work in the Caribbean in the winter. Okay, precision ag. Why precision ag equipment? Everybody in here is familiar with precision ag, I'm sure. It's basically what we are doing is we collect the imagery, we turn it into either a NDVI map, a crop stress map, a heat map, so that it can give an indication of the variableness in the field. From that, we consult with the farmers, the producers, the crop consultants, and they provide their input as to, okay, this area looks like it's stressed for some reason, this might be why, and from that we'll produce some kind of a zone map. Depending on what the end result is, what we're looking for, it might be a fertilizer prescription, it might be a seeding prescription, it may be a way to scout a field and know where to go look for the issues. We'll take this map from that point to put it in a tractor, an airplane, give it to the guy on the ground who's doing the scouting, and give them something that they can take action on. So these different layers are kind of the different steps in the process. The bottom one, it's kind of upside down, but that's natural color. This next one is a color infrared map. So that's using that fourth band that collects the color infrared imagery and then produces this NDVI map, which shows you relative variation in the field. So red is typically more stressed vegetation and green is typically healthier vegetation. The top one is actually a zone map. This is basically shape files with some kind of data in each file. So the green areas, they may be have a value of X, the red areas have a value of Y, and that's the type of file that can go into the precision ag equipment to make an application. Any questions on that? Okay, this is an example of some prescription work that we did last year on some rice. The goal was to apply a variable rate seeding prescription from the air. Some of the rice stand was thin in some areas. It was good in some other areas, so they didn't want to replant the whole field, but wanted to get some rice flown on in certain areas. So the green got a 200-pound rate. The red got nothing. It was built off of this NDVI map that was created from Imagery. The end result was we sent this file to an aircraft. They flew it on. You notice the grids. A lot of times you see prescription maps that are curved. They look like contour maps. Does anybody have experience with flying prescriptions, crop dusters?
Well, flying prescriptions, no, I meant making them, sorry.
Making the maps, okay. So when you're working with airplanes, they don't have the same functionality as ground rigs. They don't have swath control where they can shut off certain portions of the boom. Yet, there are some being tested, but they're not full production yet. So basically you have 70-foot swath width, 80-foot swath width, depending on the material and the speed. So you can't have that nice looking curved shapefile zone map that you typically see. It's not going to be accurate how it applies. So we grid it up. An airplane is also traveling 150 miles an hour, so it's covering almost 200 feet per second. So the grids are shaped long ways, a rectangle, in the direction of flight. So if you change your rates too fast, the gate can't keep up. So it's constantly going to be moving as this thing's flying, and everything is going to be maybe off a little bit. So we try to simplify the prescription so you know exactly in that green box you have that rate, in the red box you have, yeah, absolutely, $5.
I'll pay it.
So this is actually a prescription built for an airplane. The rice was flown on, and then this next slide is a different field. I believe, Brent, is it a different field or is it one of those 4 fields?
No, it's different.
Okay. So this was a different field, but it was a subsequent fertilizer prescription that was also flown on with the aircraft. Sorry?
Row rise.
This was row rice. Okay. So Brent actually did the flying. He did a lot of the work for these jobs for us. He's based in Arkansas, so he's one of our operators who does the flying for
I guess I
us.
should have asked you if I took a picture of it.
Good thing you asked me. He's double the price. So this is a 3-rate zone, 75, 50, and 0, and they flew this urea onto the rice and pushed the rice that needed pushed and didn't push the rice that didn't. So producer was happy with the results. Yesterday he was talking about it and said it worked out really well. So always glad to hear, somebody will come up and talk to you after you do a job for them and don't avoid your phone calls. So glad to get that feedback. So that was just a real quick overview of who we are, basic application of some of the work that we do. And now Dr. Price is going to